Welcome to Kushar Academy, Unleashing Potential. Welcome to Chapter 1. This is an introduction part of force. The topics that we are going to cover: contact force, non-contact force, CGS and SI unit of forces. What are the units that we will be discussing? The forces can produce different type of motions like translation, rotation, equilibrium, and uniform circular motion. In this video, we are going to cover the first three topics, that is contact force, non-contact force, CGS and SI unit of forces. So what is force? Let's discuss this with an example.
A force is a push or a pull. We can't see a force, but we can see the effects of a force. A force can move a stationary object, stop a moving object, or change its direction. A force can change the speed of an object. It can also change the shape of an object. A force is measured using a force meter. The SI unit of force is Newton. There are two kinds of forces, contact force and non-contact force. When we push or pull an object, we have applied force to the object. The object will move in the direction of the applied force. An applied force is an example of contact force. Friction is also a form of contact force. Friction goes against motion. Even though friction slows things down and makes movement difficult, there are many things we could not do without friction. Friction holds us to the ground and allowing us to walk without slipping. Friction causes the car to brake in time to accidents. The amount of frictional force depends on the texture of surfaces in contact. When the surface is smooth, there is less friction. The force that makes things fall to the ground is called gravity. Gravity is an example of non-contact force. Gravity pulls an object towards the Earth. The force of gravity also exists on the Moon, but it is not as strong as it is on Earth. When an object rests on a surface, there will always be a reaction force. When we are standing on the Earth, the reaction force balances the weight of our body, so we don't fall through the pavement. The reaction is also called normal force. Magnetic force is a non-contact force. Magnetic force only acts on magnetic objects. Iron, steel and nickel are magnetic materials. The force of magnetic attraction pulls the magnetic object towards the magnet. The interaction of forces makes the world we live in the way it is. A cycle on a bicycle experience the interaction of different forces. Gravity pulls the weight of the bicycle and the rider towards the earth, while an equal reaction force acts upwards to balance gravity. As he rides, the frictional force between wheels of the bicycle and the ground acts against the forward force, so he doesn't go too fast.
So we have seen many things, what a force can do and what are the kinds of forces. Two kinds of forces that we are describing here. One is contact forces, those forces which are exerted only and if the two bodies are in contact with each other. And second is non-contact forces. These are the forces which exert itself on the other body even when they are not in contact. In the video, we have seen the examples of contact forces. We'll be seeing the examples of non-contact forces in the later slides as well. So let's begin. Contact forces, there are many contact forces which apply, but in this chapter we have to study about these 5 contact forces. So first of all, let's define what is contact force. The force which acts on bodies when they are in physical contact. This is the important point. Physical contact means touching, are called contact forces. Example of contact force is frictional force. Frictional force is only applied when the two bodies are in touch with each other. When we are walking on the surface of sand or say tarmac or a road. So we are in touch. The tires touching the road. Without touching the road, there is no friction force. For example, a ship sailing on the river, the ship lower body is in touch with water, which is providing frictional force. Then the normal reaction force. We have seen that when we are standing, gravity of Earth attracts towards the center. But if there was no other force, according to Newton's first law, we should be pulled towards the center of the Earth. But what is holding us on the ground? The reaction force provided by the ground, so that it is equal and opposite to the attractive force of the gravitational pull of the Earth. So we are standing. Net force is zero. Tension force. We'll be studying deeply about it. Tension force is on a string thing. We are demarcating one more. Force exerted by spring. Forces exerted during collision. Collision, when say a bicycle hits a moving motorcycle, it's a collision. So the collision will happen only when they are in touch. Okay. Now, one by one, we'll study these five contact forces. First, frictional forces. What is a friction force? When the body slides or rolls over a surface, a force starts acting on the body in a direction opposite to the motion of the body. This is an important thing. The direction is opposite to the motion of the body and along the surface of the contact. Let's see. This is called frictional force. Now, these two bodies are in contact with each other. A book is in contact with table. Now, if you're pushing the book in this direction, notice this point. This point, with respect to the table, wants to move in this direction if the push is in this direction. Now, since the book wants to move towards the right, the frictional force will be in the opposite to the relative motion. That means the frictional force will be on left on the book, which we denote by small f. Clear? Study about frictional force more.
What is friction? In cold season, you must have often rubbed your palms against each other to feel some warmth. You must have wondered how this heat is generated. This is because when we rub our palms together, an opposing force is produced on the surfaces of our palms, which then generates heat and we feel warm. This opposing force is known as friction. Let's discuss it a little more. A surface is never perfectly smooth. Even very smooth surfaces possess irregularities, which is visible only through a microscope. So when two bodies which are in contact with each other, the irregularities present on their surfaces tend to interlock with each other. Now when we try to move one of the body on the surface of the other body, the interlocking of irregularities opposes the motion. This opposing force is called friction.
So we are able to see here that even the smooth surfaces are not that smooth. When it is moving, interlocking happens at this point. If we are trying to move it on this direction, it will oppose the motion. If we are moving on the left direction, again due to interlocking, it will oppose the motion. That's why friction has always a tendency to oppose the motion. And what is the direction of the friction? It is opposite to the direction of intended motion. If the motion is towards right, the friction is towards left. And if the motion is towards left, friction is towards right.
And its magnitude depends on the degree of irregularities on the surfaces in contact, while its direction is always opposite to the direction of motion. Thus, friction is defined as the force which opposes the motion between any two or more surfaces in contact. Friction can be classified into two types: static friction and dynamic friction.
Second force that we are going to study, the contact force that we are going to study, is normal reaction force. We had discussed about it. Now suppose a box is kept on a table. Now there's a gravitational pull by the earth on the box on the downward direction, and if there was not this table here, the box would have fell down. Now what is keeping a box not from falling down. It is the table, right? We can understand this. But if we are seeing there is only one force in the downward direction, which is the gravitational force, and the box is also not falling down. So there has to be another equal and opposite force which is holding the box on the table. This is known as reaction force. So let's study about what is the normal reaction force. The normal force is the support force exerted upon an object that is in contact with another stable object. So these are two in contact with each other and the table is a stable object. For example, if a book is resting upon the surface, then the surface is exerting an upward force upon the book in order to support the weight of the book. Now let's study about the normal force.
You step into an elevator. It starts going down fast. What would happen if you jumped right when it started going down? Would the ceiling hit your head? Ouch. Do you stay suspended in the air while the elevator plummets down? Let's examine the elevator problem one step at a time. First, consider a scale. You know, the kind of scale you weigh yourself on. When you step on a scale to weigh yourself, there are two forces involved. One, gravity pulls you down. Two, the scale pushes you up. What? You didn't know a scale could push? Of course it can. If it didn't push up on you, you would go crashing through the floor. This upward push is called the normal force. And yes, it is normally there. Since you're just standing there on the scale, you're not moving. Therefore, you're not accelerating. Newton's second law of motion, net force equals mass times acceleration, tells us that if the acceleration equals 0, the net force must equal 0, which means that the force of gravity pulling you down must be equal to the force of the scale pushing you up.
The third force that we are going to study is the tension force. Now, tension forces are usually in a tight string. The force that is in the tight string is known as tension force. A tension force is the force that is transmitted through a string, rope, cable or wire when it is put tight by forces acting from opposite ends. So, a tension to happen, there has to be forces on the either end of the string or wire, rope, cable, whatever the thing is. The tension force is directed along the path of the wire. The direction is along the path of the wire. See here. So, the direction of the tension force is along the path of the wire and is directed along the length of the wire and pulls equally on the opposite end of the wire. Now, the tension force here, look at the string at this point. Generally, we treat the string to be massless. In that case, the tension at both ends are denoted to be said to be same, which is T. Similarly, in this example, there is a tight string. It is and at this end. So, it has to be tight and pulled by forces acting from opposite ends. Okay, so the string is tight and the force that is holding this weight is the tension force of this string. Forces exerted by spring. Spring is also an example. You can say tension only, but the properties are a little different. So first of all, let's see the definition. Spring is found to exert a force which is directly proportional to the displacement at the other end of the spring. What does it mean? Means if this is the mean point, means the normal length of a spring, if you pull this much, the force is different. If you pull more, the force is more. If you pull even more, the force is even more. So in a spring, the more we pull, the more the force is exerted by the spring. That's what we mean here. And the force is exerted in a direction opposite to the direction of displacement. Means where is the spring going to pull? We are displacing it. We are displacing it in the downward direction. And this is the mean direction. So the length is this. We are pulling it this. So the spring force is in the opposite direction. That's what we mean by direction opposite to the direction of displacement. Here in this diagram also we can see normal mean position of the spring. So if it is ahead, the force is applied backward because it wants to retain the original length. And if it is compressed, the spring pushes it on the right. Means spring always want to reach its normal position, and whatever the direction, whatever, if we are extending it, it wants to come to the original position. If we are compressing it, again it wishes to come to the normal position. Here we are going to see same as what we were seeing here. This is the spring here. Okay, this is the normal position of the spring. A can is held here. Now a little gentle push is given in the downward direction, and as we have studied, the spring will move up and down. We are just capturing movement, and this movement that the spray will be painted is also known as sinusoidal wave. This is the sinusoidal wave, and spring is moving up and down. Now the fifth and the last force that we are going to study in this chapter is forces exerted during collision. We know what is collision. When the two or more bodies collide, that is known as collision. Suppose this is body 1, body A, and this is body B. They are moving towards each other. That means they are heading towards collision. Now, just imagine a point when they are touching each other. See, here. The ball B will be pushing ball A towards left, and in turn, ball A will be pushing ball B towards right. So what will be the result? B will start moving towards the right in this diagram. That is what we are thinking, but it can be other things also depending on the masses and velocities of the balls. And A will be start moving this. Now the important point from the Newton's third law is that this force is equal to this force, action and reaction forces. Now let's see. When two bodies collide, they push each other. As a result, equal and opposite forces act on each other. Action and reaction forces. These are colliding and these are moving. We can see here what are the changes. We can see this. A car and a truck are coming towards each other. They are colliding, and since the mass and velocity of the truck is more, both are moving in the left direction, but at a slower pace than initial. We'll be studying about this, how to calculate in which direction what will be moving. We will be moving towards non-contact forces. The forces which are non-contact forces are gravitational force, electrostatic force, and magnetic force. So let's first see the definition. What do we mean by non-contact forces? The force which act on bodies even without being physically touched are called the non-contact forces. Very simple. Or the forces at a distance. One by one we'll be studying. So first, a gravitational force. This is a famous diagram in which an apple is falling towards the ground, and this led Sir Isaac Newton to develop the theory of gravitation. So, first of all, a Newton law of gravity states gravitational force between two bodies is proportional to the product of their masses and inversely proportional to the square of the distances between them. These are the examples: an apple falling from trees, not falling off from Earth, we are not going to the different planet. All these are example. Water being on Earth, these all are example of gravitational forces, which is a contactless force. So the Newton law of gravity can be numerically equationally stated as F is equal to universal gravitational constant G into mass of the objects m1, m2 by the distance squared between them. This is the universal gravitational equation given by Newton. Now, electrostatic force. Forces due to charges are known as electrostatic force. Force exerted by the charge. We know that like charges repel each other and unlike charges attract each other. So, what is electrostatic force? Two like charges repel while the two unlike charges attract each other. The force between the charges is called electrostatic force. An example of papers being attracted by a scale is also an electrostatic force. Magnetic force, that there are two magnets and same poles are there, so it is being held on the top of it without anything being in touch. So what is a magnetic force? Magnetic force, like two poles repel while the two unlike poles attract each other. The force between the magnetic poles are called magnetic forces. There are many applications which can be done using these forces. Another example, we can see how the shape is changing. This is having iron filings in it. Dove is made with iron filings, and this is a strong magnet, and we can see that this is getting attracted. So what are the general characteristics of non-contact forces? By now we would have understood what are these. What we have said, gravitational force doesn't repel, it is always attractive force. The gravitational force is always attractive in nature, while electrostatic force and magnetic force can either be attractive or repulsive. So this is the first important point that we know. Not all forces are repulsive. Second, the amount of force of non-contact force on the two bodies depend on the distance separation. See, if two magnets are nearer, the force of attraction or repulsion is more. If they are farther away, it is less. And how does it vary? It varies inversely as a square of the distance. So how do we write? Inversely proportional to the square of the distance. So we say the distance is r, force can be written as force is inversely proportional to the square of the distance. So we have studied so many kind of forces right now. So in this video we'll try to identify the forces which are being exerted.
What are the forces acting on you right now? I want to answer this question by introducing something called a free body diagram. This is a sketch that scientists make that shows all the forces acting on an object. Each force is represented by an arrow. The size of the arrow represents the magnitude of the force, and its direction indicates the direction of the force. So for example, right now, there is a downward gravitational force on me that pulls me towards the center of the Earth. There's another force that a lot of people don't think about, but it's pretty important, and it's the force from the ground pushing me upward. For most people, it's kind of strange to think that the ground, which is something inanimate, could be putting a force up on me. But let me try to convince you that the Earth really is pushing up on me by stepping on this toy here that's supported by a spring. As I step onto the spring, it contracts. So you can imagine the spring must be trying to expand out and put a force outwards. So that force, in effect, supports me, pushes up on my feet, and balances the gravitational force down so that I remain motionless. Now the ground is very similar to this spring. The ground is just a very stiff spring, but every time you step, you compress the ground a little bit, and that is enough to make the ground create a force on you, pushing you back up. And the force of the ground upwards must be equal to the gravitational force downwards so that you stay at rest. For simplicity, we draw all forces acting through the center of mass of an object. So even though the force is acting on my feet, I can draw that force upwards as acting through my center of mass. So there are really only two main forces on you. The force of gravity downwards and something we call the normal force, which pushes you back up. The reason we call it the normal force is because the word normal means perpendicular, and the force is perpendicular to the surface that you're standing on.
What are the effect of the forces? We have studied about this since time immemorial. So now we will see what are the effect of forces. We have studied it many times. Let's recap. Force can change the state of rest or state of motion of the body. Means if you apply a force on a stationary object, it will start to move. If you are applying force on a moving object in the same direction of the motion, it will start increasing. The motion will start, the velocity will start increasing. And if the force is applied on the opposite direction of the motion, the velocity will decrease. Second point, it can change the shape or size of the body. Yes, like spring. We are applying a force and the spring contracts, like making a dove. It contracts. Squeezing a ball, it contracts. Shape or size is changed. Force on the body causes acceleration. What is acceleration? The change in velocity. Means it is somewhat related to the first point. And force is a vector quantity. Why it is a vector quantity? Because if the direction of the force is changed, the motion of the object also changes. If we are pushing an object on the north side, the object will start moving on the north side. If we are moving on the east side, the object will start moving on the east side. Just like a box, if a force is applied in this direction, the box will start moving in this direction. Again, if again a box is here and we are pushing it in this direction, the F is applied on this direction, the box will start moving in this direction. Even though the magnitude of the force is same, the result that we see on the box is different. Since with force we have to be considerate with the direction because the results are different, so we say force is a vector quantity.
In the game of cricket, when a batsman swings the bat, he hits the oncoming ball such that the ball is forced to change the direction in which it was moving. What happens if the ball is then caught by a fielder? Its motion is stopped. In both cases, you see the effects of application of force. The batsman is using force to change the direction of a moving object, and the fielder uses force to stop the motion of the moving object. Let us see the different effects of force. For this we need modeling clay, toy car, metal spring. Take the modeling clay and place it between your hands. Apply force with both your hands. You will see that the clay has changed its shape. Force has changed the shape of the clay. Now take the toy car and push it. The force applied moves the stationary car forward. If you place your hand in front of the moving car, the car will come to a stop. Now take the metal spring and press it with the fingertips. The size of the spring has changed due to force. This shows that force when applied to different objects changes the shape, size and motion of objects. Place a thin strip of plastic below a fast-running tap. See whether the falling water exerts a force. If it does, what is the effect of the force?
With this, we end force introduction.